On this slide, we talk about Veronese embedding or tuple embedding. So given n and d, so you're given this small n and this number d, those n and d are both positive integers. Then you set this capital N as n plus d, choose d minus 1. And then you define monomials m0, m1, m2 all the way to m subscript capital N. So all of them are these degree d monomials in n plus 1 variables. So all this will be more clear with an example. So you set d as 2 and n as 2. So n as 2 means there are 3 variables x, y, z. Yeah, notice that it's n plus 1 variables. So what is capital N? Capital N is 2 plus 2, choose 2 minus 1, that is 6 minus 1, 5. So what are the corresponding monomials? So there are 6 monomials: x square, y square, z square, xy, yz, xz. So 6 monomials are m0, m1, m2, m3, m4 and m5. Notice that 5 is equal to capital N here. So you have this map from Pn to P capital N. So you have this A0, A1 all the way to AN. So call this a point P, and this get mapped to this monomial m0 evaluated at P, m1 evaluated at P, and so on to mn evaluated at P. So this map rho d is called the Veronese embedding or tuple embedding. So example, n is equal to 1, d is equal to 2. So this is P1 embedded in P2 as a conic. Now we talk about a rational normal curve. So rational normal curve is nothing but P1 going into PD. So this image will be called the rational normal curve. So this is dth Veronese map of P1. So now small n is just 1 and you're going into PD. So the map is very natural. UV are getting mapped to U superscript D, UD minus 1 times V, all the way to U times VD minus 1 and V superscript D. Now this morphism is well defined because all monomials have same degree. And if U is not 0 and V is not 0, all these monomials will not vanish simultaneously. Obviously, if they vanish simultaneously, the map is not well defined because, in the projective space, you cannot have a point which is all 0 coordinates. So now we need to define a reverse map. That is a map from PD to P1. So again, we have to have two open sets, u1 and u2. So u1 corresponds to u raised to the power of t not equal to 0, and u2 corresponds to v raised to the power of t not equal to 0. These u1 and u2 cover PD. So first, acting on set u1, we have a map from PD to P1. So you just take the first two coordinates here, ud comma ud minus 1v, and on u2 again we have map from P2 to P1. So notice that we deliberately pick up the coordinate which is non-zero, so as to avoid both coordinates to become 0. Here we have to pick up Vd, and correspondingly we will pick up Vd minus 1 times u. So this is it. I mean, you can take Vd minus 1 common and say that it is u comma v. So for d equals to 3, rational normal curve, this rational normal curve is called a twisted cubic.